Good afternoon, everyone. Just wanted to know whether am I audible so that we could start up with the session without getting late. Good afternoon. Whether am I audible? Fine. So in today's session, we will be talking about certain important MCQs of light, which are full of numericals as well as your conceptual knowledge. So, without wasting time, let's start up with certain questions. What you need to do is you need to tell the answer in the chat box so that I could know how much you have learned and how much you are clear up with your concepts, and I'll help you to clear your doubts in a better manner. So, yes, let's start up with it. The very first question is on your screen. The question says two lenses of power plus 2.5 diopter and minus 3.75 diopter are combined to form a compound lens. So these two lenses are combined. One is having the power of plus 2.5 and the other one is having the power of minus 3.75. Now the compound lens, which is a combination of these two lenses, what will be the focal length of that particular lens, which is a combination of these two? So you can just have a look, think about it. I'm giving you some time. You need to tell me what is the focal length of the combined lens of these two. Hurry up, your answers are invited. Solve fast. You need to calculate the combined power first, and from the combined power you need to calculate the focal length. Okay, the very first answer is minus 40 centimeter. Let's await and look upon the next ones. Hurry up. Okay, the next comes as minus 80. Let's see. Think. Okay, great. See, if we are talking about the combined power, how we will calculate the combined power, I'll help you out in a better manner to understand this question. You have two powers with you. The very first power is 2.5 diopter and the next one is minus 3.75 diopter. So if I'll talk about the combination of these two, how will you calculate the combination of these two? By adding them. So it's P2 is minus 3.75 diopter. When you added both of them, the combined power becomes P is equals to P1 plus P2, or 2.5 plus minus 3.75. So the answer turned out to be, after calculating, it's minus 1.25 diopter. That is the combined power. Now what is the formula to calculate focal length? Power is equals to 1 upon focal length. But the focal length must be in meter. Okay. And if you look upon the answers of the MCQ, it's in centimeter. So when we have the answers in centimeter, or we need to calculate it in centimeter, what we need to do is 100 upon f. It changes to 100 upon f. So if we need to calculate focal length, what we'll do, we'll divide 100 by power. What's the power turning out to be? Minus 1.25. So 100 upon minus 1.25. When you will be solving, you will be getting minus 80 centimeter. So minus 80 centimeter is your correct answer for this particular question. So if I have talked about it, see which is the correct option among the A, B, C and D. The correct option is D. So D is the correct option for this particular question. Now moving ahead to the next one. Okay, think about the next question which is on your screen and let me know the answer. Hurry up. The question says, which position of the object will produce a magnified virtual image if a concave mirror of focal length 15 centimeter is being used? So now it has been mentioned, you need to tell which position of object, where must be the object so that it produces the magnified and virtual image. Think about it. Hurry up. Okay. So some says it's 10 centimeter. Let's see. If we are talking about concave mirror and the magnified and virtual image. So think about the mirror first. We have two types of mirror, concave and convex. The concave mirror has 6 situations for the ray diagram and only one situation gives us the image in the form of magnified and virtual. So have a look. That particular situation is C. For your better understanding, I have taken all these 6 ray diagrams. Now among all these 6 ray diagrams, you can clearly have a look and tell me which image will give, or which case is giving us virtual and magnified image. See, A, B, C, D and E all are the examples of real and inverted, whereas F is the only example where the object or where the image is what? The image is magnified and virtual. अब इस केस में ऑब्जेक्ट कहाँ पे है? पोल और फोकस के बीच में. So there is only a single case in the case of concave mirror where the image is what? Magnified and virtual. So in that particular case, where is the object? The object is between pole and focus. Now if we'll come upon this question, the focal length is given 15 centimeter. The entire focal length is 15 centimeter. So where must the object be placed? We need to look. The object must be somewhere. अगर पोल 0 पर है, focal length 15 पर है, तो object कहाँ पर है? Object कहीं ना कहीं between है पोल और focus के. So we have 4 options. We will check it out. अब between pole and focus मतलब 0 से 15 के बीच में we have only one option, that is 10 centimeter. So the correct option is 10 centimeter where the object is between focal length and the image produced is what? Magnified and virtual. Moving ahead to the next one. Yes, again a concave mirror, it's again a case of concave mirror, and is producing a magnification of +4. The object is placed. Now where is the object placed when the magnification is +4? The options are A, at the center of curvature, B, between focus and center of curvature, C, between focus and pole, and D, beyond center of curvature. Where is the object placed to get the magnification as +4? Now you all must be clear about the magnification. what does the magnification tells us? Now see, if I'm talking about the magnification is +4. +4, what does that +4 denotes? +4 denotes that the image is what? Tell me. The plus denotes that the image is virtual and erect. Image is virtual and erect. The plus denotes that. And the number 4 denotes that the image is magnified. As the number is greater than the 1, when the number is greater than 1, it shows that the image is magnified. So again the situation arises, which image is virtual, erect and magnified in case of concave mirror? Yes, very good. When the object is between P and F. Presently we have done one question, the last question, and you could see up in this particular case as well the ray diagram. The object is between where? P and F, and the image is magnified, virtual, erect and magnified. And this is very important ray diagram. When the question is in twisted form, usually they ask which is the case when the concave mirror produces the virtual, erect and magnified image, as we have discussed it right now. So when the object is between P and F. So the correct answer is when the object is between focus and pole. That is the third one. Very good. Many have answered correctly. Moving ahead to the next question. A ray of light passes from medium X to another medium Y. Now the ray of light is moving from medium X to medium Y. No refraction of light occurs if the ray of light hits the boundary of the medium Y at an angle of. So now you need to tell what must be the angle so that no refraction takes place. We are talking about refraction presently. What must be the angle? Think about it so that no refraction is occurring. Is it 120 degree, 45 degree, 90 degree or 0 degree? What must be the point of incidence so that no refraction occurs? Okay, great. Yes. Now look upon this particular diagram. You all have answered correctly. Great. When a ray of light is incident at 90 degree, जब एक ray of light 90 degree पर strike करती है तो वो straight pass होती है without any deviation. So no refraction occurs when the ray of light hits up at 90 degree. Perfectly answered. Very good. Moving ahead to the next one. Image formed by plane mirror is. Now you need to tell me the image formed by the plane mirror. Out of the 4, which correctly justifies the answer? Image formed by the plane mirror is A. Real and erect, B. Real and inverted, C. Virtual and erect, or D. Virtual and inverted. Out of these 4 options, what do you notice when you see the image in case of a plane mirror? When you see yourself in the plane mirror, I must say. So, hurry up, tell your answers, whether you see it as, okay. Hurry up. You need to answer fast. Great. Fine. Yes, if we are talking about the image formed by the plane mirror. The image formed by the plane mirror, if you look upon this particular diagram or the image I'm talking about, see, the very first thing we need to notice is the distance. Distance between the object and the mirror, if this is our mirror, and the mirror and the image is always the same. So distance remains same. Second, does the boy gets inverted? Is it upside down? No. If the boy's head is looking over there at the same place, means अगर head ऊपर है तो head ऊपर ही दिख रहा है, नीचे नहीं दिख रहा. नीचे दिख रहा होता तो हम उसे upside down बोलते हैं और inverted बोल देते. But क्योंकि ऊपर ही दिख रहा है, we will term it as what? Erect. So if we are talking, the image is virtual and erect. अगर आपको head नीचे दिखता तो उसे हम क्या बोलते हैं? real and inverted. But if the head is above, we'll say it as virtual and erect. Second, the distance of object from the mirror. If the distance is 5 centimeter from the mirror of the object, the same is goes with the image. The image is also 5 centimeter from the mirror. So these 2 points you need to keep in mind. And for this particular question, what is the image formed by the plane mirror? It is virtual and erect. Good. Okay, moving ahead to the next question. Now, light from the sun falling on a convex lens will converge at a point called. Now we all know that the convex lens is a converging lens. Converging means when many rays are coming parallel, they all just meet up at a point. So light from the sun falling on a convex lens will converge at a point called. Where will the rays converge? A, center of curvature. B, radius of curvature. C, focus. Or D, optical center. Okay, think about it carefully. You're answering correct. All the rays which are coming parallel to the convex lens will converge at a point called. Great. Okay, yes. So many of you have answered correctly. If I'm talking about the convex lens. Convex lens is a converging lens. Converging means when many rays are coming from infinity, they all will reach up where? If this is a principal axis and we have focus, so all the rays bend and move towards focus. So if we are talking about what is the point where all the rays will converge, the correct answer will be focus. Or we all know the rule, parallel to the principal axis passes through the focus. So all the rays which are parallel to the principal axis and are falling from the sun will all meet up at focus. Now this next question is extremely important. Either it can come in 2 or 3 marks, and if you will observe, it is an NCERT exemplar question in the form of MCQs as well. So think about this question carefully. The question says a 10 millimeter long all pin is placed vertically in front of the concave mirror. So what is the 10 millimeter? It is the height of the object जिसको हम observe कर रहे हैं. तो 10 millimeter long all pin is placed in front of the concave mirror. A 5 millimeter long image of the all pin is formed. Image is formed of 5 millimeter. The object was of 10 millimeter. And it is formed at 30 centimeter in front of the mirror. जो image बनी है वो in front of the mirror बनी है. And that too 30 centimeter. You need to find out the focal length. Now calculate it fast. I'm giving you a minute. You need to think, what is 10 millimeter? It is the height of the object. And what is 5 millimeter? It is the height of the image. So we could notice that the image size is shorter than the object size. Okay, think about it fast. A 10 millimeter long all pin is placed vertically in front of the concave mirror. A 5 millimeter long image of the all pin is formed at 30 centimeter in front of the mirror. Find the focal length. Giving you 1 minute. You can think about it. Fine. We have started getting the answers. Think. Okay. See, I'll help you how you can calculate this question. If we are talking about 10 millimeter long all pin, so that means what is the height of the all pin? The height of the all pin is what? It is 10 millimeter. So the height of the object is 10 millimeter. And if I'm talking about the image, what is the height of image? The image is, yes, it's 5 centimeter. So we know the formula of magnification is height of image upon height of object. The height of image is 5 upon 10. Since we are talking about image and image is inverted, we have taken it -5. Now if I could solve, it's coming -5 upon 10, that is equal to minus v upon u. We are talking about what? We are talking about lens or the mirror? You need to tell me fast. Yes, mirror. So we will take it as minus v upon u. So height of image was +5, the height of object was +10, and we have put it equal to v upon u. That is the formula of magnification. Now if you will solve it, what is the value of v given? It is already given that the image is 30 centimeter in front of the mirror. Since it is in front of the mirror and everything towards the left is taken as negative, so we have taken the image as negative क्योंकि वो in front है. जब भी in front mention होगा, हम कैसे लेंगे image or object distance को? negative. So we have taken v as negative. Now if I'll put 5 upon 10 is equals to minus 30 upon u. After solving, you will be getting u is equals to minus 60 centimeter. We know that u is always in negative. So u is 60 centimeter. I hope I am clear till here. We have got the object distance. Now the question is demanding the focal length. So how we will calculate the focal length? What is the formula? We will go up with the mirror formula. The mirror formula is, yes, it's 1 upon f is equals to 1 upon v plus 1 upon u. We have calculated that the v, it's already given, it's minus 30, and if I'm talking about u, it's minus 60. Now if we'll solve, we'll get the focal length after solving. If I'll take upon the LCM, it would be coming, I guess, 1800. That would be the perfect one. And then 60, okay, 30. So it's coming minus 90 upon 1800. And after reducing, I got it as minus 1 upon 20. So what is the focal length? The focal length turned out to be minus 20 centimeter. I hope this question is clear to all of you, how we need to solve. What is the mirror formula? What are the formulas of magnification? The very first formula is magnification is equals to height of image upon height of object, and the second formula is minus v upon u. We equate both of them, we got u, and then we put up in the mirror formula. So the correct answer out of the 4 turned out to be the C1, that is minus 20 centimeter. Great. Moving ahead to the next one. The speed of light in air is 3 into 10 to the power 8 meter per second, whereas the speed of light in water is 2.26 into 10 to the power 8 meter per second. What is the refractive index of water with respect to air? So you have the speed of light in air, that is the same, that is 3 into 10 to the power 8 meter per second. If we are talking about the speed of light in water, it is 2.26 into 10 to the power 8 meter per second. What is the refractive index? Now there are two formulas of refractive index. One is with the Snell's law, that is sine I upon sine r, that is sine to the angle of incidence to the sine to the angle of refraction. And the other formula is all about speed of light in vacuum upon speed of light in medium. So we have to just simply do that because we have speed of light in both the cases. You need to divide speed of light in vacuum upon speed of light in medium. Perfect. So what is the formula of refractive index? We will calculate together. Refractive index is equals to speed of light in vacuum upon speed of light in medium. Speed of light in vacuum is 3 into 10 to the power 8 meter per second, and the speed of light in medium is 2.26 into 10 to the power 8 meter per second. Now if we'll solve, 10 to the power 8 and 10 to the power 8 will get cancelled, and we'll divide and we'll get 1.26. That is the refractive index. So the refractive index is 1.26. Oh sorry, it's coming near about 1.32. So the correct, it's 2.26, sorry I misunderstood, it was 1.32. so the correct option among the four is 1.32, which is the B one. Moving ahead to the next question. An image of an object is produced on a screen. Now an image is produced on a screen which is about 36 centimeter using a convex lens. The image produced is about 3 times the size of the object. Now image is 3 times just increased if you're talking about the size of the object. What is the size of the object? Think carefully and let me know the answer. An image of an object is produced on a screen which is 36 centimeter using convex lens. The image produced is 3 times the size of the object. What is the size of the object? So now we are talking about lens. Think about 3 times means what is given to you? You are given the magnification. Hurriedly think about it. Yes, I'm giving you a minute or so. You can try solving it out. Yes, hurry up. Good. They have given us 36 centimeter. So what is 36 centimeter? It is the distance of the image. What is magnification? Magnification is 3. Think about it. Which formula would you use? What are the formulas for magnification of the lenses? There are 2 formulas for the magnification of lenses. That is V upon U and height of image upon height of object. So if we'll proceed, what is the correct formula? The correct formula which we will be using over here is, we need to find out U, the distance. So magnification of lenses is equals to V upon U. The magnification given is 3. V, that is the distance of the image, is 36 centimeter given to us. We need to calculate U. So if we will interchange the positions, we will get U is equals to 36 upon 3. So we will reduce it and we'll get 12. So the correct option, if I'm talking about over here, is the A1, that is the 12 centimeter. What is this? If I'm talking about the size of the object. So the size of the image is given. That was, okay, I took it as the distance. Size of the image was given. So if we'll do up with the formula, just a second. Magnification is equals to height of image upon height of object. So magnification was 3, height of image was 36, and we need to calculate the height of object. I was considering that we need to calculate the distance of the object. Extremely sorry. So it turned out to be height of object is equals to 36 upon 3, and then we solved and the height of object turned out to be 12 centimeter. So the correct answer for this question is 12 centimeter. Very good. Moving ahead to the next question. A diverging lens will produce. Okay, so the diverging lens will always produce, first one says a virtual image, second one says real or virtual image, third we have always real image, and fourth none of these. So you need to tell a diverging lens will produce. First of all, we need to think which is a diverging lens, whether it is a convex lens or concave lens. Yes, convex lens is a converging lens and concave lens is a diverging lens. And if you remember, we have just two ray diagrams for the diverging lens, only two ray diagrams, and both of the ray diagrams are giving us which type of image. I'll show it to you. See, if I'm talking about the concave lens, you can see the rays are getting diverged after striking from the lens. They are just getting diverged. So this is a diverging lens. Up object, say we are comparing the image. So you can see the size of the image is reduced and the image formed is virtual. So when the object and image both are placed on the same side, in the case of lens, the image formed is virtual. So the correct answer, if I am talking about over here, is always a virtual image. Moving ahead to the next one. Which of the following mirror is used by the dentist to examine a small cavity? Now we are talking about the mirror. Which mirror is used by the dentist? कौन सा mirror dentist use करते हैं cavities को observe करने के लिए? Whether it is a convex mirror, plane mirror, concave mirror, or a combination of convex and concave. Think about it. See, if I am talking about convex mirror gives us, means the size of the image is diminished. If you have drawn the ray diagrams, you are well aware that the size of the image reduces if you are talking about the concave mirror. And if I'm talking about convex mirror. But if we talk about concave mirror, we have recently discussed about a ray diagram few questions back, that when the object is between pole and focus, the image is virtual, erect and magnified. So the dentist has to see the image in the form of magnified and virtual and erect, which will be given by concave mirror, and the object must be placed between focus and pole. You can even see this image depicts how the mirror is showing the image, and the image is little bit magnified so that the dentist could work upon it clearly. So the correct option is concave mirror. Very well answered. Moving ahead to the next question. Refractive index. Now refractive index, the very first part says depends on the wavelength of light used. Second is the actual property of the substance. Third, depends on the angle of incidence. And fourth, none of these. Which is the correct option for them? So if you're talking about refractive index, whether it depends upon the wavelength, whether is the actual property of the substance, it depends upon the angle of incidence, or none of these. Think about it carefully. See, refractive index depends upon certain situations. Basically, if you would like to understand, there are two basic factors on which refractive index depends, that is temperature and wavelength of light. Refractive index doesn't depend on the angle of incidence. Okay, so there are basically two factors which you almost know, that is the temperature and wavelength, on which the refractive index depends. So if I am asking about here, we could see out of these four options, there is nowhere where temperature is mentioned. So the correct answer would be A. It depends upon the wavelength of light used. Moving ahead to the next one. A convex lens of power P is immersed in a water. How will its power change? अब एक convex lens है जिसकी power P है, that is immersed in a water. उसे पानी में immerse कर दिया. How will its power change? उसकी power पे क्या फर्क पड़ेगा? Will the power increase, or it will remain unchanged, decrease, Or the fourth option says increases for red and decreases for blue. Think carefully and let me know the answer. What will happen to the power of convex lens? Think. How will the power change? Okay, some says that it will remain unchanged while the other says it will decrease. See, power of, if I'm talking about convex lens, it will decrease. Why? Because if we talk about the values of focal length will increase. Okay? If I'll immerse something, immerse means you have to dip it in water or you have put it up in the solution. डुबाना किसी चीज को. So we know that the power formula is 1 upon f focal length. Yes, power is equals to 1 upon f, 1 upon focal length. So the power, what will happen to the power? If I'll dip the convex lens in water, its focal length, if I'm talking about focal length increases. Now power and focal length are inversely related to each other. If the focal length is increasing, what will happen to the power? Power will decrease. So the correct option is the C1, that the power will, what will happen to the power? The power of the convex lens will decrease since the focal length will increase. So the question can also come, what will happen to the focal length? You will write that the focal length will increase. And what will happen to the power? The power will decrease. The last question for today's session, think it about it carefully and I want the answers by all of you, please. It says a hole is made in a convex lens. Then, so we are using the lens for making up the ray diagram of observing the image. Now, if that lens has a hole in it, what will happen? The very first part says the hole will appear in the image. Image में भी hole आएगा. Second says the image of size decreases. Image का size कम हो जाएगा. Third part says image intensity decreases. Image की intensity brightness कम हो जाएगी. और D part says no change. Okay, so think. Hurry up. What will happen? See, you can correlate with this question with your NCRT question in which a convex lens was darkened or it was covered with the black paper. One half of the convex lens was covered with the black paper. So when we covered the lower half of the convex lens with the black paper, we observed that image was completely formed, but the intensity of image got reduced. Yes, so same will happen here. If a hole is made in the convex lens, then what is the correct observation? Image intensity decreases. That would be the correct option. So this was the last question for today's session. So we'll end up the session with the thought that consistency. Consistent actions create consistent results. So if you are working regularly upon something, it will obviously give you the desired results you want. Kindly share the video and do subscribe the channel if you haven't done till now. Thanks for giving your time.